Another lesson we might be able to learn from ants is how to manage traffic. So this is a trail of leafcutter ants. These ants have cut pieces of leaves and they're bringing them back to the nest. And during rush hour, there can be tens of thousands of ants going back and forth along this highway. But they never have traffic jams. How can that be? Recently, I started collaborating with a team of physicists to try to understand how leafcutter ants avoid traffic jams. We've set up video cameras along their foraging trails in the rainforests of Costa Rica, and then we introduce obstacles like a metal sheet with just a thin opening that allows one worker at a time to pass through. Now I can guarantee if something like this happened on one of our highways here in Houston, traffic would be backed up for miles and it would last for hours. But somehow these ants quickly figure out the fastest way around the obstacle, and as soon as one or two ants do that, all the other ants follow and the normal flow of traffic resumes. Imagine if we could model our driving behaviors after what these ants are doing. We might actually be able to do this if we figure out more about what the rules these ants use are. Perhaps we could design programs for self-driving cars that would eliminate traffic altogether. Actually, computer scientists have already been trying to design programs that are modeled after the behavior of ants. Since the 1990s, computer scientists are working on trying to figure out how it is that ants are so good at finding the shortest distance between their nest and sources of food. And what we know is that they do this by letting other ants know where they've been with the use of chemical pheromones. And the ants tend to always follow whichever path has the strongest pheromone trail. So even if the first ants out of the nest choose their path randomly, the ants that follow behind it are likely to follow the shortest path, because over a given period of time, more ants will have gone back and forth along the shortest path, so it accumulates the most pheromone. Using a similar approach with virtual ants and virtual pheromones, computer scientists are designing algorithms that can not only allow a delivery person to find the shortest distance, the shortest route that would connect all of the addresses on their lists, but also to design the most efficient wireless networks.